So, keeping this in mind as the vertex formula, if we have our value h comma k from this, so we want to find what is our vertex here. Well, our k here is our y, and the opposite sign of our -6 is our x value. So there's the vertex. And if we look at what is in the A position here, it's positive, so it will go upwards. Now, a few other things. What is our axis of symmetry? Well, it would be our x value, so x equals 6. And what is our minimum? Since it's opening up, our minimum is our y value, so the minimum is 5. All right, again, this is in this vertex form. Our a value is negative here, so this is going to open downward. And our vertex, this is 7, opposite sign, -3. So what is our axis of symmetry? X is -3. So what is our maximum here? Since this is opening downward, our maximum is going to be 7. Now for example 3, we have to use that special technique of finding what is needed to put that in the vertex formula. So we're going to use completing the square here. We've separated our c term out there, and we're going to start to put it in that form. The x goes there, minus. Now this is our b term. What's half of our b term? 5. So that's what we put here. And then to get our c term, we're going to square the -5. That gives us 25. But to keep this equivalent here, we've added 25 here, so we have to subtract 25. So when we do that, we end up here with a 4. This is now in that special vertex form, so our vertex will be a +5, opposite sign, and our 4. And since our a out here is positive, this will go upwards. Our axis of symmetry is x equals 5. And in this case, our minimum is 4. Okay. In example 4, we want to, again, apply what we know about converting this into the vertex formula. We're going to factor out a 3 here and get x squared minus 4x. And we, in a sense, factored out a 3, so we have to put that over there. And now we're going to make this a perfect square trinomial. X there, minus there, half of 4 is 2. Now we're going to square -2, and we get a 4. But if we add 4 there, we have to subtract 4 there. So this becomes that when we factor it. This is a -12 plus 17 gives us a +15. 5. So our vertex now for x is going to be the opposite of this, which is a 2, and our k value is 5. And our a value up here is positive, so it opens upward. Our axis of symmetry is x equals 2, and our minimum will be 5. We can leave that one up here and work on this one. Now we're going to factor out a negative 2 from here, which is what we've done. Now we're going to use that technique. X, half of this is 2. And then we square that. That gives us a plus 4. We now have to subtract that plus 4 as a minus 4 here. Minus 10. So we get then here, this will be a positive 8. Minus 10 gives us a negative 2. So our vertex is going to be a opposite sign of this, a 2 and a negative 2. Now, since our a value here is a negative, it's going to open downward. And our axis of symmetry is x equals 2. And our maximum now will be a negative 2. Okay, so again, lots of stuff going on here, and hopefully you can master this technique. They didn't give you the hardest examples here. Now this is page 48 here. And as we look at these, we see this is sort of in this form. And it's going to be plus, since there is no value, we could think of our k as 0. So our vertex is going to be opposite sign, 5, 0. Now, when we are asked to graph this, and by the way, our axis of symmetry is x equals 5. When we're asked to graph that, we know this is our vertex. A out here is positive 1, so this will open upwards. So we can put our vertex in there as 5, 0. But these values are going to be so high that we're going to be off of this little graph here. So let me work on something. So we're quickly going to run out of space on this graph. So I'm going to have the x values just as these, but the y values, the boxes, will be 5. So we have here 5, 0 is right there. But then 0, 25 would be 0, 1, 2, 3, 4, 5 is right there. And then we have 7, which we're off, and 7 is 4 up over here somewhere outside of our graph. So it goes off this way and comes down this way. So just a piece of it there. This graph could have been over this way a little bit, but that's where it is. Okay, let's look at this one now. First off, note that this is negative. So again, there is a value out there. So our vertex here will be opposite sign, negative 5, 0. So using that same technique here, negative 5, 1, 2, 3, 4, 5, 0. So just sketching it in, there's our maximum, which is 0. It's opening downwards because of this negative here. And there is our vertex. And it has this shape. So for example 3, they want us to find the vertex. So again, using this technique, we're factoring out a 2, finding what we would need to complete the square here. X goes there, minus goes there. Half of our b term is 2. Squaring negative 2, we get a positive 4. But if we add 4 here, we must take away 4. So this then becomes plus a negative 8 plus 18. So finally, 2x minus 2, the quantity squared, and a negative 8 and a positive 18, this becomes a 10. So our vertex will be a negative 2 and a 10. Our axis of symmetry will be a negative 2. Now, since our a value is positive, this is going to face upwards, so let's plot our vertex, negative 2, 10. So we're going to go negative 2 right there, and each y value will be 5. So this gets to look a little bit like so. And again, if you put that in your graphing calculator, you can get a nice curve there. Oh, I did that one wrong, didn't I? It's opposite sign here. Sorry about that, I was distracted. So we got a, from here, it's the opposite sign. And when I plot it, it's this. Now, if we put y is, or I should say x is 0 in a t-chart here, what will our y-intercept be? Well, this is a 0. This will be a 0. It will be 18. So again, using these as 5, 10, 15, 18 is right about there. And then over here, there's an 18. Gives you an idea what the graph will look like. Now, for this one, again, it would be, little throwback there, x squared plus 6x. Our 2 goes over here, parentheses, squared, plus 2. This is x plus 3. Square the 3, we get a 9. Factor that into this, but we've added a 9, so we have to subtract a 9. So this gives us a 7 then here. A negative 7. So our vertex will be opposite sign. Okay, watch that now. Negative 3, negative 7. So our vertex, negative 3, negative 7, axis of symmetry, x equals a negative 3. And our y-intercept over here will be a 2. So 0, 2, remember these are 5. So over here, 1, 2, 3, 1, 2, 3, about like so. This will look sort of like that. So in example 5, we are factoring out a 2 from our first two terms here, bringing over the 11, and then completing the square, taking half of a negative 2, getting a negative 1, squaring the 1, gives you a positive 1, but to keep it equal, we have to subtract the 1, and of course we factored out a 2, so this then becomes a minus 2 plus 11, so this is going to end up being a positive 9. So our vertex will be opposite sign, a positive 1, positive 9, axis of symmetry, x equals 1, and this is our a value is positive, so it's going to open up a 1, 9, so a 1, 9 is about there, and if we want our y-intercept, if x is 0, this will be 11. So there's 9, 11 is about here, and about there, so our line goes like so. Okay, not too bad if you know the technique, and hopefully you've had now a lot of practice. Now we have a few moments before the 20 minutes, so let's take a look at this form again. This is the vertex formula, and they're giving us what the vertex is, and they give us 1 point. This happens to be the y-intercept. So what they want us to do is, from this information, substitute into this formula, and then let's see if we can find out what the rule is that governs it. And that's where we'll pick up in our next set of pages.